Alright, for this example we're looking to graph the parametric equation, show the orientation, and then eliminate the parameter. Alright, so we're going to make a table again. Choose our t-values, and then we'll have our columns represented by the equations for x and y. Alright, then we'll get our x and y ordered pairs that we want to plot. Alright, so to choose the t-values, you'll notice this time our t-values are given to us as familiar radian measures from the unit circle, and these angles will go into the sine and cosine functions. Now, the smallest t-value that we have there is negative pi over 2, and we can choose values all the way up to pi. So we have to include in our table the smallest t-value, and we also have to include the largest t-value. Now what values you pick in between is completely up to you. But since we're talking about, looks like familiar angles from the unit circle, let's draw our unit circle and let's label the quadrantal angles. So we're starting at negative pi over 2. Now what does that mean? Remember, that means that the angle is rotated in the negative direction one quadrant. So there's negative pi over 2. Now we're supposed to go up from there. So we're supposed to move now in the positive direction. So starting at negative pi over 2, the next nice quadrantal angle then would be 0. So I'm going to plug in 0. Now you can plug in anything you want to in between, as long as you have an accurate and complete graph. You're welcome to plug in as many or as few points as you need to get an accurate and complete graph. So the next nice quadrantal angle would be pi over 2. And then the next one we come to is actually the stopping one. This is the largest value, that's pi. If you want to include any measure in between, if you want to do pi over 4, pi over 3, any of those measures that appear within those quadrants, that is fine. That's completely up to you. You can plot as many or as few points as you need to feel like you get a complete and accurate picture that fills up our piece of graph paper. So I'm going to choose these 4 t-values, and we're going to plug them in. So we have 2 times cosine of negative pi over 2. Alright, you can use your calculator for all of these, that's totally fine. If you think back to the ordered pairs, you might not need to use your calculator. Okay, so we know for all of these that the cosine value is the first point, first number in that point, and then the sine values are the second number in those points. So cosine of negative pi over 2 is 0. 2 times 0 gives me 0. Alright. Let's see, we have negative 3 times sine of negative pi over 2 plus 1. Alright, so negative pi over 2, the sine value of that is negative 1. So that's 3 times, negative 3 times negative 1, that's a positive 3 plus 1, we get 4. So the ordered pair, 0, 4. So I'm going to plot that. That's an x value of 0, y value of 4. And then I'm going to label that with the t-value. This is the smallest t-value, so this is where the path will start. Alright, so let's plug in 0. So that's 2 times 0, or sorry, 2 times cosine of 0. Cosine of 0 radians, that's 1. 2 times 1 is 2. Once again, you can use your calculator. I'm just using what I know from the unit circle, because it's just right there. Sine of 0, that's 0. Negative 3 times 0 is 0. 0 plus 1 is 1. So we get 2 comma 1. Plot that and label that, and write down my t value next to that. T is equal to 0. Alright, we'll plug in a t value of pi over 2. Alright, cosine of pi over 2, that's 0. 2 times 0 is 0. Alright, using my unit circle, sine of pi over 2 is 1. So that's negative 3 times 1. That's negative 3 plus 1 gives me, is that negative 2? So 0 comma negative 2. That happens at a t value of pi over 2. And the last one, we have a t value of pi. 2 times cosine of pi. Cosine of pi is negative 1. 2 times negative 1 is negative 2. Sine of pi, that's 0. Negative 3 times 0 is 0. 0 plus 1 is 1. So negative 2 comma positive 1. And that happens at a t value of pi. That's the largest t value, so here's where the path stops. Alright, so you want to be careful of something here. When you go to connect these, alright, you start at the smallest t value, connect the dots until you get to the largest t value, and then you stop. Now you might be tempted at this stage to try to connect from here to here. But that path is actually not included in our parametric equation because the path is going to stop at the last point we plot. It does not continue to connect back to negative pi over 2. Okay, so there is no red line here. There's no graph there. Okay, so be careful there. A lot of times we're tempted to connect those dots to form a complete kind of circle there, but that is not the case. The path stops at the last point we plot. Alright, what is the orientation? Alright, the orientation will move from smallest t to largest t. So there's our orientation. The last thing we want to do is eliminate the parameter. So we want to eliminate t. Now this time we have an equation that involves cosine and sine. So this one is going to go a little differently. So I want to show you the way that I want you to eliminate the parameter. And this is what you'll see in your homework as well. Okay, so to eliminate the parameter, when sine and cosine are in the equation. So what we're going to do is we're going to solve both equations for sine t and cosine t. So that means I'm going to take both of the equations and I want to get sine t and cosine t by themselves on one side. Okay, we're going to do that for both equations. So you notice here we're not solving for t. This is the big difference. We're solving to get by itself on one side sine t and cosine t, not just t. In order to get t by itself, you would have to introduce the inverse functions, and that's not what I want you to do. Okay, let's come back up here. We have x equals 2 times cosine t. Alright, and then we also had y is equal to, is that negative 3 sine t plus 1? Okay. So for both of these equations, I just want you to get the trig function and its input angle by itself. Okay, when you do this, you always do your adding and subtracting first if there's any adding and subtracting to do. And if there's not, then you're just going to do your multiplying and dividing. 2 times cosine t. To get rid of the 2, I'm going to divide both sides by 2. So we have x divided by 2 is equal to cosine t. Okay, so we've solved for cosine t. The next equation, once again, don't do any division by 3 yet. We do our adding and subtracting first. Be careful there. That's y minus 1, not y times the negative 1. So if you get negative 1 times y, that's a problem. Okay, so be careful there. I see that all the time. So be careful when you're subtracting 1 from both sides. That's what you do first. It's y minus 1. Those are not like terms. They sit side by side. Alright, so now you have negative 3 times sine t. Once again, still trying to get sine t by itself on one side. I'm going to divide both sides by negative 3, and I have to do that to everything on the left-hand side. Okay, so now I have y minus 1 divided by negative 3 is equal to sine t. So I'm going to use this and I'm going to use this. Now that's not our final answer yet, because remember we have to get an equation that involves x and y but eliminates the parameter t. Okay, so how do we do that? This seems like we're kind of stuck. Alright, step 2, we are going to use the Pythagorean identity. So we're going to use sine squared t, t representing the input angle, plus cosine squared t is equal to 1. So this is that Pythagorean identity that we've discussed in the past. Alright, so what we're going to do is I'm going to write this as something squared plus something squared equals 1. Now officially what sine squared t means, and let's just go ahead and write this out, it means sine t quantity, that ratio, squared. So cosine squared t really means cosine t, that ratio, that quantity squared. So our goal is to use the Pythagorean identity and replace where we see sine t and cosine t with the sine t and cosine t from our parametric equations. So we're going to use the Pythagorean identity and we're going to replace sine t and cosine t with what we just solved for. So y minus 1 divided by negative 3 is what we got for sine t, and we're going to replace that with what's on the other side. For cosine t, we're going to replace that with x divided by 2. Alright, once you get to here, you can stop. You have completed the requirement to get an equation that eliminates the parameter t and only involves x and y. So this is the procedure that I want you to use every single time you have a parametric equation that involves sine and cosine. Alright, so this is the way. Okay, so make sure that you have this written down somewhere. This will pop up on your test, it will pop up in your homework. So make sure that you're familiar with that. Now, before we go any further, let's think about an optional simplification to kind of relate what we have in our picture with what we know about equations. So optional. I'm going to square both of these fractions. So I'm going to square the top, so that's y minus 1 quantity squared. Square the bottom. A negative number squared, remember, is a positive number. Sometimes people get negative 9 there. Be careful. Okay. A negative number squared is a positive number. So this fraction is overall a positive result. The second fraction, I'm going to square the top, so that's x squared. Square the bottom, that's 4, equals 1. What does that look like the equation of? So from our conic section notes, we should say, oh, that's the equation of an ellipse. Right? Both fractions are added together. What's the orientation of this ellipse? Remember, for ellipses, we're looking for the larger denominator. Since the larger denominator is underneath the y, then the orientation will be that the major axis is parallel to the y-axis, right? So it's a vertical major axis. What is the center of this ellipse? So remember, it's always the number that comes after the variable. So, and it's the opposite sign, right? So the y value of the center is 1. Now, notice that there's no number that comes after x. So imagine that would be like x minus 0 squared. You would not write x minus 0 squared. You would say, well, x minus 0 is just x squared. So the x value of the center then is just an implied 0. Okay, now what about the a value and the b value? See, the a value would be the larger of those two. So a squared is 9, that means a is 3. B squared would be the smaller of those two for an ellipse, so that's b is equal to 2. So that means that the picture we have should be an ellipse, or part of an ellipse, with a center at 0, 1, and going up and down from the center should be a distance of 3, and then going left and right should be a distance of 2. So let's see if that is correct. Alright, so if we go up here, it looks like we do have a center of 0, 1. That looks right. If I go up from here 1, 2, 3 units, I get a point. If I go down from here, I get 1, 2, 3, I get a point. So those are the two vertices of that ellipse. If I go to the right 2 units, I get a point on the end of the minor axis. If I go to the left 2 units, I hit a point at the end of the minor axis. So we actually do get exactly the picture that we expect from that equation. And notice that we don't get, for the parametric equation, we don't get the entire ellipse, we get only a portion of it, and that's okay. But I feel really confident in the picture that I drew based upon the equation that has the eliminated parameter.